So welcome students. In this topic, we are going to look at the uses of distance formula. So what are the different situations in which we can use distance formula to solve our questions? So the first important situation is if you are given 3 points A, B, C. If you are given the coordinates of 3 points A, B, C, using distance formula, we can check whether these 3 points are collinear or not. So collinearity of 3 points. Collinearity of 3 points. If the coordinates of 3 points are given, we can check whether the 3 points are collinear or not using distance formula. So how do we do this? If the 3 points are collinear, then sum of any two distances, you need to find all the 3 distances, distance AB, distance BC and distance AC. If sum of 2 distances is equal to the third distance, then the 3 points are collinear. If not, they are not collinear. So very easily by finding the distances, you can check whether the 3 points are collinear or not. I hope this is very clear. The second use is if the points A, B, C are not collinear. If the points A, B, C are not collinear, obviously they form a triangle. So you can determine the nature of triangle. You can determine what kind of triangle ABC forms. For example, is it an equilateral triangle? Is it an isosceles triangle? Is it a scalene triangle? So you can determine whether it is an equilateral triangle, isosceles or scalene just by finding the distances. You find all the 3 distances. If all the 3 distances are equal, then it is an equilateral triangle. If only 2 sides are equal and the other side is not equal, then it is an isosceles triangle. So if all the 3 sides are different, then it is a scalene triangle. You can also determine whether it is a right angle triangle or not. You can also determine whether it is a right triangle. If the largest side square is equal to the sum of squares of other 2 sides, then it is a right angle triangle. Or you can also determine whether it is a right isosceles triangle. Right isosceles triangle, right? So if the condition for right angle triangle, Pythagoras theorem, is also valid, as well as if 2 sides are equal, then it becomes a right angled isosceles triangle. So using the distance formula, if you're given 3 points, we can determine what kind of triangle the points form. Next, if you're given 4 points A, B, C, D, if you're given 4 points, you can determine the nature of quadrilateral. You can determine the nature of quadrilateral that is formed. If you are given 4 points A, B, C, D, you can determine whether A, B, C, D forms a parallelogram or a rhombus or a rectangle or a square using just distance formula. So you just need to find 6 distances to determine which figure the 4 points form. So you need to find the lengths AB, BC, CD and DA. These are the sides, and AC, BD, AC and BD, which are the diagonals. So if you find these 6 lengths, you can very easily determine which kind of quadrilateral the 4 points form. So first, if the opposite sides are equal, if AB is equal to CD and BC is equal to DA, and the diagonals are not equal. First, suppose that the diagonals are not equal. The pair of opposite sides are equal and the diagonals are not equal implies a parallelogram. Next, if opposite sides are equal and the diagonals are also equal, if AB is equal to CD and BC is equal to DA, if opposite sides are equal as well as the diagonals are equal, then the figure becomes a rectangle. If all the sides are equal, if AB is equal to BC is equal to CD is equal to DA and the diagonals are not equal, then it becomes a rhombus. And the final figure, if all the sides are equal and the diagonals are also equal, the figure formed will be a square. So this is how you check whether the figure is a parallelogram or a rectangle or a rhombus or a square. So you need to find 6 lengths. From these 6 lengths, we can determine the nature of quadrilateral. We can see whether the quadrilateral is in any way special. So as you have to understand, if the quadrilateral is a square, it automatically becomes a parallelogram. So as we go down, the strictness of the figure increases. So if it is a rectangle, it is already a parallelogram. If it is a rhombus, it is already a parallelogram. If it is a square, it is a parallelogram as well as a rectangle as well as a rhombus. So these are the specific conditions for parallelogram, rectangle, so on. So these are the 3 major uses of distance formula: to check the collinearity, to find the nature of the triangle, to find the nature of the quadrilateral. Thank you.